Welcome everyone, both here in the Aula and also those who are following this via streaming. My name is Ylva Berger, and the Department of Psychology has appointed me as Chair of Defense for Heidi Umbach Hansen's public disputation. Master of Neuroscience Heidi Marie Umbach Hansen will later today defend her dissertation publicly for the PhD degree. The title of the dissertation is Musical Sensibility and Motivations for Music Use, a twin study of the underlying structure, personality correlates, and genetic and environmental underpinnings. Heidi Marie Umbach Hansen will now give her trial lecture. The topic for the lecture was set by the committee. She will lecture on the topic Recent Advances in the Neuroscience of Emotions and the Contributions of Music Research to these developments. Heidi, the floor is yours.
Good morning, everyone, and thank you so much for being here today, and thank you so much to the committee for this really exciting topic for my trial lecture. I will get to neuroscience, music, and emotion in just a minute, but first we're going to watch a little video clip. Okay, so this is obviously not a controlled experiment, but it does show how powerfully music can engage us. And today, we begin to look at how the brain makes that possible in a minute, but first we have to cover some of the basics. So we're going to begin by going through what are emotions and studying emotions through music. And then we move on to pleasure as the foundation, and I'll introduce the human reward system. And then we move from music perception to pleasure, and then peak pleasure. Then we move from pleasure to complex and messy feelings, and then I'll introduce some evidence from neuroimaging and taxonomic studies. And then finally, I'll give the big picture and the key takeaways. Okay, beginning with the basics. So let's start with a seemingly simple question. What is an emotion? And although it may seem obvious, we all know what emotions are until we're asked to define them. Then things get a little bit more complicated. So is it mainly in our bodies, like that gut feeling? Or is it mainly in our minds, the way we interpret and appraise a situation? The answer is both and more. So broadly speaking, we can say that an emotion is best understood as a complex pattern of responses to events that matters to us. And it involves multiple components that interact to produce what we experience as an emotion. So first, there is the physiological component, meaning changes in the body, such as heart rate, breathing, hormone release. And then we have the behavioral components, which are the actions or expressions we show in response to an emotion. So these can be facial expressions, for example. And then finally, the cognitive component, the way we interpret, appraise, and think about a situation. And understanding this complexity is key in emotion neuroscience, which aims to gain in-depth understanding of how these emotions are embedded within the brain, using methods like neuroimaging. And more specifically, we can say that an emotion is an immediate, brief, and specific response to an external or internal stimulus. And just to clarify, emotion can be distinguished from a feeling, which is a subjective experience of an emotion. So, for example, the emotion might be fear, while the feeling is I feel scared. And emotions are also different from a mood. A mood is longer lasting and is more diffuse, and it is not necessarily tied to any specific cause. And then finally you have affect, which is an umbrella term covering various affective phenomena. And definitions get even trickier when we try to categorize specific emotions. And in fact, psychologists, they are still divided into two main schools of thought. So one is the discrete theory of emotion, which proposes that emotions can be categorized into a small number of innate, distinct, and universal emotions. And this idea was popularized in the Pixar Inside Out, where each emotion is a character: joy, sadness, anger, fear, and disgust. And this movie was partly inspired by psychologist Paul Ekman's work, who originally at least proposed 6 basic emotions that are universal across cultures. So it's these 5, and there's also surprise, but allegedly it was difficult to create like a little anime that was always surprised. Yes. So the second school of thought states that emotions can be described along 2 or more dimensions, and these collectively are called dimensional theories of emotions. So in this framework, emotions are they are not separated boxes, they're points on a spectrum, and built from shared ingredients of valence and arousal. And one of the most influential is a 2-dimensional circumplex model of core affects. So you have on the horizontal axis is valence, so it can range from it ranges from unpleasant or negative to pleasant and positive. And on the vertical axis is arousal, ranging from low to high activation. So high arousal emotions are those you really feel strongly in your body, like nervousness or excitement. And so an example is feeling excited is also a state of positive affect. And then you have low arousal emotions, which cause fewer physiological effects like fatigue or calmness. And we mostly focused on this model throughout the lecture. Okay, so why we use music to study emotions? Well, first, affective science is a broad and interdisciplinary study of emotions and moods, stress, motivations, looking at both brain processes and psychological mechanisms. And affective science is also tightly linked to how we think, build relationships, our personalities, and how happy and healthy we are. And then why music? Well, it provides a very useful tool for affective science. First, it is considered one of life's greatest sources of pleasure. And it also reliably evokes emotions, and these can range from everyday to more complex mixed emotions. It also activates all of the major regions involved in emotion processing, making music not just a source of pleasure, but also a valuable tool for science. And studying both music and emotions more broadly can of course help us better understand the emotional brain, and at the same time it has real-world relevance from promoting health and well-being to education and therapy. Okay, so now we've covered, now we know how emotions are defined, and now we're going to dive into some of the more neuroscience perspective that give rise to our emotions. And in this section, I'll first introduce the reward system and pleasure as a fundamental building block of the emotional experience, and I'll highlight some key findings from music research. Okay, so the human reward system supports motivation, learning, and memory, but importantly, its activity is directly tied to our subjective feelings of pleasure. And pleasure is sometimes called evolution's boldest trick, because it motivates us to seek things that are crucial for survival and reproduction. And we humans, we can derive pleasure from many types of rewards. There are primary rewards that are directly linked to survival and reproduction, meaning food or sex, for example. And then you have secondary rewards. They are more abstract and learned through experience, such as money, social media, music. And of course, in modern life, where many rewards are easily accessible, these same mechanisms can drive maladaptive behaviors, such as addictions to substances or social media. And human neuroimaging studies have shown that rewards across very different sensory domains, whether it's food, money, or music, they all engage the same mesolimbic circuit in addition to specific sensory cortices and connecting pathways. Okay, so here the brain consists of two hemispheres, and this figure shows a side view of the right half of the brain, highlighting the position of the main structures involved in the reward system. And the reward system isn't really a single structure, it's a network spanning several regions, and while the boundary isn't really fully agreed upon, there is broad consensus on the following core components. So you have the midbrain dopaminergic nuclei, the ventral tegmental area here. And then you have the striatum, both the dorsal and the ventral, and especially in the nucleus accumbens is a really key reward structure. Then you also have areas in the prefrontal cortex, like the orbifrontal cortex. And to better understand how the brain processes rewards, we can also break the system into two key components. And this framework has mostly been developed by Kent Berridge and colleagues at the University of Michigan, and mainly using animal models. So the two components most relevant here are wanting, meaning the desire or craving and reward-seeking behavior. So it's characterized by approach behavior, for example, seeing a piece of chocolate cake, craving it, and then wanting to, or trying to obtain it. And then we have liking, which is the immediate pleasure or enjoyment we get when we actually receive the reward, such as savoring the cake. And these two components, they map onto partly distinct neurochemical or messenger systems, which can modulate activity in the brain. And when it comes to rewards, two neurochemical systems stand out, that is dopamine and opioids. And wanting depends strongly on dopamine signaling, but it doesn't generate pleasure itself. Instead it boosts how much we want something, making it feel important and worth pursuing. Liking, on the other hand, relies more on the opioid system within hedonic hotspots, which are denoted here, throughout the reward system. And opioids are believed to produce the actual feeling of pleasure or the satisfaction. So in relation to the reward system, I'm gonna address primarily two questions that have been addressed in music research. And I'll begin with the first, and that is, are there specific mechanisms underlying music-induced pleasure? So as I mentioned, brain imaging studies have shown that very different rewards all engage the same core reward network in addition to specific sensory pathways. So food through taste, and music through hearing. And reward research has often assumed that this sensitivity to rewards is a general trait, that if someone responds less to one type of reward, like food, they're also less responsive to rewards in general. But this view is likely too simplistic, because people show these domain-specific differences. Some are more responsive to food, and others to social or aesthetic rewards, like music. So this suggests that this reward sensitivity is multidimensional. So the key question becomes whether sensory pathways which differ across modalities could actually play an essential role in generating more specific kinds of rewards, like musical pleasure. And researchers such as cognitive neuroscientist Robert Sator at McGill University in Canada and colleagues at University of Barcelona have really done some groundbreaking work on individual differences in reward sensitivity, helping to identify which aspects of the reward system are general and which are specific to music. And one of the most important findings from this work was the discovery of substantial individual differences in how sensitive people are to music rewards, and specifically the identification of a condition called specific musical anhedonia. So these individuals, they have completely normal hearing and music perception skills, and they also have normal responses to other rewards like food, but they do not experience pleasure from music. So in other words, music just simply doesn't feel rewarding to them. And one neuroimaging study compared people with this musical anhedonic condition to those with normal and high sensitivity to music reward. And results showed that only the anhedonic group, which is in red, and green is those that have average music reward sensitivity, and those in blue are those that have high music reward sensitivity. And then you see the solid bars represent when they are listening to music. And then we see the activity in the striatum, one of the key areas for reward processing. And results show that only the anhedonic group had reduced activation in the nucleus accumbens when listening to pleasurable music. And importantly, their responses to other rewards, which are in the striped bars, were normal. So this suggests that the reward system itself, it works properly, but fails to engage specifically during music listening. And they also found that the functional link between the right auditory cortex and the nucleus accumbens was reduced or absent in the anhedonic group, whereas in the intermediate, it was intermediate in people with average sensitivity and enhanced in those highly sensitive to music. Yeah, so that's noted here. And this is parts of the auditory cortex. So in other words, the degree of pleasure people experience from music maps onto how strongly these auditory and reward regions interact. And later, structural neuroimaging studies have corroborated these findings. And so the key takeaway is that music's ability to move us depends on the integrity of the communication between the auditory and the reward system. And specifically, the connectivity between the right superior temporal gyrus, which is here, and the nucleus accumbens, which is here, and then this pathway specifically via the orbifrontal cortex. So without that interaction, music cannot engage the circuitry needed to generate pleasure. Then we move on to the second question. What role do opioids play in music evoke pleasure? So most of what we know about wanting and liking, those two components of rewards, comes from studies with primary rewards, meaning food, for example, or drugs in tightly controlled settings and often in animals. But research has begun to show that these systems are also engaged by music. So for example, both brain imaging and pharmacological studies demonstrate that dopamine is released when people listen to music they enjoy, both during the wanting and liking components, but in distinct reward structures during the expectation and the experience of the reward. And also changing dopamine levels can alter the experience of musical pleasure. But this does not rule out that other neurochemicals might be involved. So here we will take a look at the role of opioids in pleasure for the secondary rewards. And one way that researchers can study the role of the different neurochemical systems in regard to the hedonic experience of liking is through music chills. So chills, they are strongly embodied affective experiences to music that are characterized by pleasurable feelings that tend to reach peak intensity at precise moments during listening to often familiar and favorite musical pieces. Oh. And they are very scientifically useful because they represent moments of peak pleasure. So they provide a way to study the mechanisms of wanting and liking in action. Note that although many associate chills with actual goosebumps, studies have shown that this is not the most common marker of chills. But rather, chills are often accompanied by increased physiological responses and bodily sensations that are tied to the autonomic nervous system. So that can include tingles in the skin, cold skin sensations, pillow erection of the on the arms and legs, trembles, quivers, shivers down the neck or spine, spreading down the limbs and body, and so on. Okay, so to illustrate how that might look, I'm gonna show a video clip. This is from a Christmas broadcasting in 2017. So it's Andrea Day and Alicia Keys, and this is really like a guaranteed chill inducer for me. So it's a medley, so I've only included like a short snippet. Yeah, so I'm gonna watch. So chills, they are often connected to surprising moments or unexpected harmony, change in volume, entrance of a new voice. And for me, in that video, it's really like the gospel choir coming in. So I cry, I get goosebumps, heart racing, I get sweaty. And I'm not alone, and I'm not unique. So it's chills, tears, goosebumps, cry, goosebumps. Yeah, pour racing, that's a new one. Okay, so moving on to some actual empirical work. Because of this physiological arousal, such peak pleasurable moments can be measured not only through self-reports, but can also objectively be measured using physiological signals like heart rate, temperature. Yeah, like shown here, see the chills moment, and then you can see the physiological correlates. And because of this heightened arousal, we can place chills in the upper right quadrant of the circumplex model over here. And as I mentioned earlier, studies of primary rewards in humans and animals indicate that opioid mechanisms most likely mediate the hedonic response or the actual feeling of pleasure. But the question is, does this also apply to music? So only a handful of studies have tested this, and one recent study led by Bruno Leng gave participants either naltrexone, which is a drug that blocks the brain's natural opioids, or a placebo. In this case, it was vitamin D, while they listened to their favorite music. And they also used pupillometry as a measure, to measure pupil dilation, which is actually a key objective marker of arousal. And interestingly, self-reported pleasure didn't change, but pupil responses were significantly reduced during chills. So this points to sort of a split between what people say they feel and what we can actually objectively measure. Yeah, so for those who took vitamin D, it was normal, but reduced for those who took the opioid blocker. So taken together with similar findings, the key takeaway is that opioids appear to modulate peak pleasure through the autonomic nervous system and arousal, influencing the intensity of the experience, rather than modulating the valence level of the experience. So this will put chills somewhere around here. And this aligns with models where valence and arousal are partly separate dimensions of emotion. Okay, so far we've been talking about the reward system and pleasurable experiences, but clearly there's more to our emotional life than pleasure. So what about the neural basis of more specific emotions like sadness or more complex, even mixed subjective feelings? And that's what we'll look at next. So we move from pleasure to complex and messy feelings. So in everyday life, whether it's in social interactions, the appreciation of art, or just daily fluctuations in mood, emotions, they are often varied, they're blended and complex. And stated in the heading here, feelings are messy, and the feelings we study in affective science should be too. So one example is bittersweet. It mixes both positive and negative feelings. Or my favorite, cuteness aggression. So when something is so cute, you just want to squeeze it, which is very familiar to me. So these feelings, they don't really map neatly onto the basic 6 or the valence arousal model, which have focused primarily on non-blended or discrete feelings. And tools based on these models, like fixed categories or simple scales, only capture a fraction of experience, so it makes it hard to connect theory with real-world emotions. And the idea of this complex feeling is gaining ground in affective science, but it remains understudied. So, like I mentioned, the chills clip I showed earlier only tells part of the story, so it's a 3-part medley. It includes a Christmas song, and then also Alicia Keys' song, Holy War, which carries a powerful political message. And across those 5 minutes, I actually feel a wide range of emotions. I feel love, I feel compassion, I feel togetherness, I'm moved, I feel hope, strength, nostalgia, and even some moral emotions and responsibility. Again, not unique. So it's touching, achingly beautiful, powerful, inspiring. Can't put into words the feeling this gives me. Moving, gratitude, vibrating on love. That is what love sounds like and religious experience. And while it's well known that music can certainly evoke pleasure or convey specific emotions like sadness or fear, its effects are usually broader and more diverse. And that's why music is such a valuable tool for studying these more complex and possibly unique human experiences. And in this regard, researchers have proposed 9 main affective states commonly elicited by music, at least in Western populations. And these have been operationalized in the Geneva Emotional Music Scale, a domain-specific model of musical emotions, and includes joy, sadness, wonder, tenderness, nostalgia, tension, power, peacefulness, and transcendence. And these, in turn, can be grouped under the broader factors like vitality, sublimity, and unease. And whereas the vitality and unease, they echo more like the classical arousal and valence dimensions, the sublimity category is linked to beauty and transcendence, and it suggests that music evokes experiences that go beyond these basic models. And in one neuroimaging study, Trust and colleagues used this scale to map these emotions in the brain. And they found that these more complex music-evoked emotions, they share core system with the reward system, or with the pleasurable valence music, and basic emotions like sadness. But they also involve regions not usually considered emotional, including motor circuits and memory areas like the hippocampus. So find this increased activity being associated with feelings such as tenderness and peacefulness. So these networks go beyond a simple two-dimensional valence arousal space, showing distinct patterns across categories and frequent blends between quadrants. So there are many studies using such like music-specific or high-dimensional models like the Geneva Music Emotion Scale. But over the past few decades, there have been many neuroimaging studies have used music to evoke a wide range of emotions like joy, sadness, tension, or beauty. The challenge, of course, is that many of these studies have had very small sample sizes and making these findings less reliable. And to address this, Stefan Kölsch conducted two meta-analyses, one in 2014 and one in 2020. And for those unfamiliar, meta-analysis combines results across studies to reveal consistent brain patterns, giving us a more reliable picture of how music engages the brain. So the 2014 revealed two key findings. Positive valence music activates the reward network, just as has been found in meta-analysis of other rewards, but also find activation in anterior hippocampus, and this suggests that music-evoked emotions extend beyond rewards alone. And in the 2020 meta-analysis, this covered 47 neuroimaging studies. They found a largely similar picture, namely that music-induced emotions activated the amygdala and the hippocampus. So these findings indicate that music-evoked emotions, they engage a broader set of brain regions than reward alone, and this is also consistent with what was found in the TRUST study. So when we think about emotion in the brain, most people think of classic emotion centers like amygdala or reward circuits. The hippocampus, on the other hand, is usually framed as the memory center. So it's crucial for cognitive functions like memory, learning, and navigation. But the meta-analytic evidence I just presented suggests it contributes to emotion too, which is consistent with animal research linking it to emotions tied to social life, for example, like bonding and attachment. This role has been less recognized in humans, possibly because affective neuroscience has often focused on single or more basic emotions like fear, rather than emotions that arise in social context. But music can easily evoke such emotions through synchronization of movements, which in turn can facilitate feelings of closeness, increased trust, and cooperation. So it may even trigger release of neurochemicals like oxytocin that are tied to bonding and empathy. So one theory proposed by Kölsch is that the activity changes in the hippocampus are at least in part due to attachment and bonding related emotions promoted by emotional and motoric synchronization to the music. And because we still know so little about how the brain supports social bonding, music may be a highly useful tool for further investigation of this topic. And finally, I just wanted to highlight some recent taxonomic and cross-cultural research showing that music evokes a wide range of feelings that go far beyond those more classic models of emotions. So in this study by Cohen et al., they found that people consistently report at least 13 distinct feelings, like triumphant or dreamy, and these are arranged along continuous gradients. And more broadly, emotion science is moving past the idea of 6 basic emotions or 2 dimensions, and evidence now points to dozens of distinct emotions that do not fall neatly into boxes, but they form this high-dimensional continuous space. And of course, such mapping has the potential to guide future neuroscientific work. Okay, so now that we've explored some of the details, I'm going to zoom out and look at the bigger picture, what these findings mean for our understanding of reward and emotion. So in terms of reward mechanisms, while specific brain mechanisms may differ across reward modalities, the reliance on this functional or anatomical connectivity between sensory regions and the reward system may represent a unifying principle driving these individual differences in specific rewards. And insights and methodological approaches from music reward may serve as a framework for studying individual differences and reward type specific brain pathways in other domains. And then in terms of the neurochemistry of secondary rewards, dopamine seems necessary both for wanting and liking in secondary rewards. Opioid signaling may influence the overall intensity of the hedonic experience via arousal rather than mediating the pleasurable experience per se. So overall, this suggests that partly different neurochemical mechanisms in primary versus secondary rewards. And in terms of complex and messy feelings, music gives us a unique window into the richness of our subjective experience. And it shows us that emotional processing in the brain is not limited to the reward system and classical emotion centers, but also involves structures like the hippocampus, which may generate those tender, positive feelings we sometimes get from music. And finally, like, our emotional lives are richer and more interconnected than traditional models allow. And I think the future lies in embracing this messy complexity and beginning to map the full emotional landscape to build a more comprehensive atlas of human emotions. And that can be used in neuroscientific investigations. And then, speaking of music, the hippocampus, social bonding, and tender positive feelings, here is a final clip to go full circle.
Depths of my soul, I love you.
Thank you.
I would like to thank Heidi Marie Umbach Hansen for this chills-inducing trial lecture. And I would also like to remind the audience that the public defense of the dissertation will take place here at 12:15. Thank you very much. Welcome, everyone. My name is Ylva Berger, and the Department of Psychology has appointed me as chair of the defense for Heidi Marie Umbach Hansen's public disputation. Master of Neuroscience Heidi Marie Umbach Hansen is about to defend her doctoral thesis entitled Musical Sensibility and Motivations for Music Use, a twin study of the underlying structure, personality correlates, and genetic and environmental underpinnings. On the 13th of May 2025, Heidi Marie Umbach Hansen submitted her thesis to the University of Oslo and requested the opportunity to defend it for a doctoral degree. Professor Bruno Lang from the Department of Psychology, University of Oslo, has been the main supervisor for the dissertation. The co-supervisor has been Espen Røysamp from the Department of Psychology, University of Oslo. Following the proposal by the Department of Psychology, The Faculty of Social Sciences appointed the following people to serve on the Adjudication Committee. Professor Ana Butkovic, Department of Psychology, Faculty of Humanities and Social Sciences, University of Zagreb, Croatia. Professor Stefan Kölsch, Department of Biological and Medical Psychology, University of Bergen. And Professor Daniel Quintana, Department of Psychology, University of Oslo. The committee has come to the unanimous conclusion that the thesis is worthy of defense. The Faculty of Social Sciences has agreed to this. The candidate held her trial lecture earlier today on the 29th of August. The topic for this trial lecture was set by the committee: recent advances in the neuroscience of emotions and the contributions of music research to these developments. The committee found that the trial lecture had been held to their satisfaction. What now will follow is the viva, or the public defense of the thesis. The following two people have been appointed to serve as official opponents: Professor Ana Butkovic as first opponent, and Professor Stefan Kölsch as second opponent. Everyone in this room is entitled to serve as an ex auditorio opponent. If anyone present wishes to do so, he or she will be given the chance to speak after the two opponents have finished, and is asked to report their request to me before I invite the second opponent to begin. Today's schedule will be as follows. The first opponent will give an account of the thesis, followed by a discussion between her and the candidate. This will last for approximately 1 hour and 15 minutes, that is until circa 13:45. We will then take a break until 2 o'clock. Please remember that the schedule is tentative and subject to the dynamics of the discussion. After the break, we will hear from the second opponent. Finally, any ex auditorio opponents will be yielded the floor. So I hereby call on the first opponent.
First of all, thanks for the invitation and for the introduction. And I hope you hear me well. I've been having some issues with the microphone, so if anything happens that you don't hear me well, please just let me know. So I'm really excited to be here and to be in this role and to present the results of the dissertation of Heidi Marie Umbach Hansen. And I'll try first to open the slides that I have prepared. One of the reasons that I'm really excited is that this thesis combines different things that I've been doing in my research and that belong to my research areas, because I've been doing studies in personality and in behavior genetics and also in music psychology. So all of this kind of combines also my research interests. So this is one of the reasons why I'm really excited to present to you the results. So I will start with the introduction. Most scholars today agree that humans are, to some extent, musical, and that musicality can be expressed in various ways. And we have also seen during the trial lecture how there's just a small amount of people who don't feel satisfaction from music. And further on, musicality is considered as a multidimensional phenomena. So it can, as an umbrella term, combine different musical phenotypes that can be studied and have been studied during the research so far. And they encompass several traits that have distinct multiple biological mechanisms. Also, we heard some of it during the trial lecture. And for this thesis, two phenotypes were chosen. One is musical sensibility, and the other are motivations to use music. So the musical sensibility can be defined as a tendency to seek out and be emotionally and aesthetically engaged by music. It's considered a stable disposition and conceptual, distinct from constructs related to knowledge, expertise, preferences, but sharing common grounds with certain aesthetic and general aesthetic concepts. As a psychometric model in this thesis, the module 2 of the Musabach inventory was used. But in terms of theoretical models that can be associated and explain the musical sensibility, two models were chosen or mentioned in the introduction. One is the Brett-Swema model by Jocelyn and Jocelyn Westphal, and model grounded in appraisal theories of emotions. The second phenotype that has been used in the thesis are motivations for music use. And they describe different ways people engage and reasons why people engage with music. A lot of different models have been put forward with different number of specific motivations to use music, but they're mainly theoretical. So they barely looked at the reasons people use music, but without a theoretical background. One theoretical approach that could be used is the uses and gratification approach. But in terms of psychometric model that's used in the thesis, that's the module 4 of the Musabach inventory. One of the way to explore some specific music phenotypes is to put them in relations to existing structural models. And one that was chosen here, and also starting point in many research studies, is a personality model. So to see how musical sensibility and motivations of music fit in the broader theoretical framework, and to see how they are related with specific personality traits. Two models were chosen. One is a model with 5 broad personality traits and also personality facets, which are narrow personality traits. And because a model with 5 broad traits is a dominant model in personality theories, it was quite clear why this one was chosen. And also the trait empathy, because it's not represented so clearly in the chosen model with 5 broad factors, was also chosen, and it's defined as a dispositional capacity to understand and feel the experiences of others, and it can be divided into emotional and or affective and cognitive component. To see how these studies that are part of this dissertation fit in the broader picture of previous studies, I will give you just a brief overview what's known from previous studies of personality and musical phenotypes research. So strongest associations are obtained with openness to experiences or open-mindedness. It's called differently in different models, so like both openness factor. And links can be found in specific studies with all 5 broad traits, but the strongest one are with openness. Also, there are quite limited number of studies that look at a facet level of personality hierarchy, so we really don't know that much of how musical phenotypes are related to facets. So this is one thing that dissertation is really helping us to find out. And also studies using empathy found significant associations, and specifically for fantasy facet that belongs to the cognitive component of the empathy trait. The second part that's interesting, beside putting the musical phenotypes in a broader structure or broader trait phenomena as personality, is how and why individual differences in musical phenotypes appear. And the field that tries to answer this question is the behavior genetics, and it does that with different types of research designs. The one being most popular and frequently used is a classical twin design, which was also used in the dissertation, which compares the monozygotic and dizygotic twins reared together. The difference between monozygotic and dizygotic twins is that the monozygotic share all their genetic makeup, while dizygotic on average share 50% of their genetic makeup, so we can compare them and see how much genetic and environmental influences contribute to individual differences. So far, behavior genetic research on musicality has shown that, as the meta-analysis shows, on average, heritability of the spectrum of musical phenotypes is 42%. So it shows that musical phenotypes are heritable, so individual differences in musical phenotypes can be attributed both to genetic and environmental factors. And also what behavior genetics research so far has shown, that there is some genetic overlap of the musical phenotypes and some non-musical traits. I have chosen two here to show you the picture, and that's the study that looked at the overlap with intelligence, and also the study that looked at the overlap with openness. So we see that there is a genetically mediated association between musical and non-musical traits. Which leads us, hopefully, clearly to what was done as part of this dissertation. So the main goal was to advance our understanding of the nature and origins of a set of effective musical dispositions by illuminating their structure, personality correlates, and etiology. This was done through 3 papers that were published, and I will go through aims of each paper and then present each paper by itself. So the first paper was called The Underlying Architecture of Musical Sensibility, 1 general factor, 4 subdimensions, and stroke genetic effect. And 2 aims that the candidate and her research team wanted to establish was to empirically assess the phenotypic structure of musical sensibility and to investigate the genetic and environmental underpinnings of musical sensibility. For the second paper, the title was The Role of Big Five Personality Domains and Facets in Musical Sensibility, a twin study. And the 2 aims were to map the relationship between Big Five personality traits and musical sensibility phenotypically, and both at the level of broad personality domains and the level of conceptually narrow facets. And then to examine the etiology of these relations and assess the degree to which personality-related genetic and environmental influences overlap with the genetic and environmental basis of individual differences in musical sensibility. In paper number 3, the title was Dimensions of Musical Use Motivations, Their Genetic and Environmental Underpinnings and Association with Big Five and Empathy Traits. And 2 aims were to assess the genetic and environmental etiology of individual differences in 4 dimensions of motivations for music use, and to examine the phenotypic and etiological overlap with facets of the Big Five and empathy. So now we'll delve more deeply into paper number 1. As said previously, this paper dealt with the architecture of musical sensibility. And participants were from the Norwegian Twin Registry. There were 100 of them, and there were full twin pairs, but also unpaired twins, more women than men, all of them in middle adulthood, and there were both monozygotic and dizygotic female and male twins, more, again, female and more monozygotic twins. As previously said, to measure musical sensibility, module 2 of the Musabeck inventory was used as a psychometric model. And now a little bit more information about the module itself. It has 24 items divided into 4 scales: emotional sensitivity to music, personal commitment to music, music memory and imagery, and listening sophistication. Items on a scale are rated on a 5-point response scale from 1 to 5. Strongly agree, strongly disagree to strongly agree, and Cronbach alphas were really satisfactory, ranging from 0.81 to 0.19. And results regarding the first aim to empirically assess the phenotypic structure of musical sensibility. The candidate ran 3 competing models, confirmatory factor analysis model. One was the correlative factor, the higher order factor, and the third was a B-factor model. The 3 models were compared depending on their fit indices. And because there was quite little difference in fit indices, also the theoretical and interpretative links were looked at, and the decision was made that the higher order structure was identified as the model that best succeeded in balancing fidelity to the data with good measurement properties, meaning precision, reliability, interpretability. Additionally, it successfully reproduced the lower order constructs, so that there are 4 factors or 4 facets of a musical sensibility factor, and that also align with the hypothesized psychometric model. So the middle one is the model that was considered the best. The second aim was to investigate the genetic and environmental underpinnings of musical sensibility. So the analysis included both multivariate models included for facets or the univariate model on a total score. Both models ran determined that the EA model fitted the data best and shown that the heritability estimates for the facets range between 0.49 to 0.65, or for the whole factor result or scale of musical sensibility, the heritability estimate was 0.64. Also, what you can see in the little diagram there is that there were significant genetic and environmental correlations between the facets of the musical sensibility, showing that there is an overlap between the facets of the musical sensibility score. This is also shown in figure 2 for the facets, and nearly identical results were obtained when the scores corrected for acquiescence were used in the analysis, which is a nice way to show that the response style didn't really induce any bias in the heritability estimates that were obtained. Some considerations that are related to paper 1 are related to modeling approach. So the confirmatory factor analysis models were used, so how they are assessed, which fit indices are used, then whether a different modeling approach can be used, such as exploratory factor analysis or network approach, and also the possibility of using more theory-driven multivariate models, such as independent or common pathway models. Of course, there are, as in any study, some sample issues related to representativeness, selection bias, variance, decomposition, power, sex differences, and some measurement like self-reports or use of exclusively self-reports, and also if there are any other important facets of musical sensibility that are not captured by the module 2 of the Musabak inventory. So this is the overview of the first paper, and now I can move to the second paper, which looks at the role of big 5 personality domains and facets in musical sensibility using twin data. So data or participants were again from the Norwegian Twin Registry. The sample, the number of participants differs a little bit from the first paper because it depends on people having valid personality and musical sensibility scores. So the total number was 2,592. There were, again, paired and single responders, but the main structure in terms of male, female, and monozygotic, dizygotic twins is quite similar to what I've shown in paper 1. So for musical sensibility, the same scale was used as in paper 1, so I'm not going to repeat that. But for personality, the big 5 2 inventory 2 was used, which is a 60 items measure that measures 5 broad domains and also 3 facets per domain, so in total 15 facets. And items are rated on a 5-point scale from strongly disagree to strongly agree. And again, the reliability indices were satisfactory in line with what you see in other studies using this measure. The first aim of this paper was to map the relationships between big five personality traits and musical sensibility phenotypically. So this is quite a large table, but what we see is both the correlations and also the regression analysis, which showed that which also informed which personality domains and facets will be included in behavior genetics analysis that followed in the paper. And results were in line what I have shown you in previous studies. So in terms of broad personality traits, all but conscientiousness showed significant associations, with openness showing the highest association with musical sensibility. And with facets, again, strongest association were obtained for openness, three openness facets. The strongest one with aesthetic sensitivity. Again, what was nice that what the candidate did is that she removed the item that mentioned music explicitly in the item, the BFI2 item, so, and repeated the analysis so that the conceptual overlap was a bit controlled. And we see that the association remained significant, substantial, both for openness and the specific openness facet that included that music item. So to examine the genetic and environmental overlap, only the personality domains and facets that were significant in the regression analysis were chosen. And so for domains that were open-mindedness, negative emotionality, and agreeableness, and as you can already see from the figure here, there are more solid lines on the top showing the genetic overlap than on the bottom part of the figure. So there's more genetic overlap between personality domains than environmental overlap, but there are some solid lines also down, so there is some environmental overlap. And you can see that all phenotypes were heritable. And in terms of facets, two facets were chosen based on regression models that were aesthetic sensitivity and compassion. And again, you see the similar picture, like solid lines above showing genetic overlap and more dashed lines appearing in the lower bottom, so showing less environmental overlap, but still existing between personality facets and musical sensibility. This is also shown in this figure with red bars showing genetic overlap or genetic correlation and blue bars showing the environmental one. So the red bars are higher and more prominent in the figure than the blue bars. Finally, in terms of broad personality domains and musical sensibility, we can see that there is part of variability in musical sensibility that it's not shared with personality, so genetic and environmental influences that are unique to musical sensibility. But then there's also some overlap that it's larger genetically, 28%, and smaller but still existing 5% environmental overlap with personality domains. Some considerations that are related to paper 2 are repeating what we already have seen related to paper 1, some sample issues, representative selection bias, variance, decomposition power, and sex differences. Some measurement that are also similar as in paper 1, like self-reports or other important facets of musical sensibility. But also we can talk about the personality model that was chosen and conceptual overlap that might exist between the measures. And also in terms of analysis, we can talk about multiple testing corrections or selection of variables in twin models as one of the differences that, or choices that might be done differently or influence the results in the paper. And finally, the third paper, dimensions of music use motivation, genetic and environmental underpinnings and associations with big five and empathy traits. Again, the participants came from the Norwegian Twin Registry, 2,611 individual twins. Again, some of them were in twin pairs and some single responders. the composition of the sample is similar as in previous two studies, so I will not repeat that. Here we have another scale to measure motivations for music use. That's the module 4 of the Musabak inventory, so I will tell you a bit more about it. It has 4 subscales of motivations for music use: musical transcendence, emotion regulation, social bonding, and musical identity and expression. It has different number of items per scale. The items are rated on a 5-point strongly disagree to strongly agree scale, and Kronbach alphas were also satisfactory. The personality scale was the same as in study 2, so I will not describe it, but the empathy scale, now it's used for the first time, so I will tell you a bit more about that one. The brief interpersonal reactivity index with 16 items was used, assessing individual differences in empathy through 4 facets: fantasy, perspective taking, empathic concern, and personal distress. So the first 2 belong to cognitive empathy, and the last 2 belong to affective empathy. Here we have a 7-point scale ranging from does not describe me at all to describes me very well. And again, we have satisfactory reliability indices. The first aim of this study was to assess the genetic and environmental etiology of individual differences in 4 dimensions of motivations for music use. So here we see the phenotypic correlations between the 4 scales, and also the twin correlations that helped chose the model that was tested. And what we see finally, that the best fitting models were AE models again, showing that all 4 motivations for music use were heritable. And one thing that is worth noting also is that in terms of twin correlations pattern, there were some indications that a C factor might be important, at least for some motivations for music use. Also, yeah, that's what I already said. So also the model fitting results confirm that there is really a little choose between 2 competing models. So this one was more chosen for parsimony and some specific reasons, but there is also a reason to believe that it's worth exploring if there is some shared environmental influences. The second aim of this paper was to examine the phenotypic and etiological overlap with facets of the Big 5 and empathy, which is nice because we have the same level of analysis for personality and empathy. And we see that there were bivariate phenotypic correlations between extroversion, agreeable, so between all 5 factors and empathy. So again, that's in line what we see in previous studies, that there is significant association with different personality traits. And again, I'm just pointing that you see that the highest bars are in the part of the picture where open-mindedness was. So again, showing that that factor is related the most to musical phenotypes. By use of the regression models, again, specific personality facets and empathy facets were used to do the genetic and environmental overlap analysis. And what we found, or what was found, is that, again, there is part of the genetic and environmental influences that are unique to motivations for music use, and part that are overlapping both genetically and environmentally with personality and empathy facets. Again, the overlap was larger for genetic factors and smaller for environmental influences. And in terms of which specific facets contribute the most to this overlap, we see that aesthetic sensitivity facet of the openness factor and the fantasy facet, again, in line with some previous studies that were done with empathy traits, are the ones that appear the most important for all 4 motivations for music use. So the BFE02 and EDFA are those two facets that appear the most. So some considerations related to paper 3. Again, some sample issues. Measurement, now we have a new module, so of course there are some considerations regarding how this module 4 works. And again, in terms of analysis, the things that I already mentioned, and of course the modeling approach that it's used in this paper. Some supplementary analysis was done also and presented in the dissertation that's not present in these 3 papers, and I will briefly mention also them. So the first one was exploratory analysis of the dimensionality of genetic and environmental covariance structure of musical sensibility, which showed that both the genetic and environmental covariances metrics have the unidimensional structure. Then the phenotypic association between musical sensibility and the 4 dimensions of music use motivation, so between the 2 musical phenotypes that we have. And we see quite strong associations between the 4 motivations for music use with the factor score of musical sensibility. So especially you see from with transcendence and identity, the correlation is 0.76, so that's quite a strong association. And then phenotypic association between musical sensibility and empathy, because in paper 2 we only saw the personality model, but not the trait empathy included. So here we see also significant correlations with global empathy and all 4 empathy facets. And when we compare the regression models that included only personality model, compared to the one that included personality and empathy facets, we see that empathy comes in as an important predictor of musical sensibility, and agreeableness and agreeableness facet stops being one, with fantasy and empathic concern as specific empathy facets becoming important on top of aesthetic sensitivity that is the most important predictor. So some additional considerations coming from this supplementary analysis are if the 2 Musabac models are really different concepts or 2 sides of the same coin, which of course can lead to different modeling approaches like network analysis of the pooled items. The question, which personality model and which personality measure, because we see that there is some competing between agreeableness and empathy when we combine them in regression analysis, and gene-environmental interplay that was not looked into, but that can play a role in all of this that's happening. So to conclude this my presentation of the dissertation, I want to say that I personally and we as a committee feel that this dissertation has specific scientific contributions, giving or answering some of the questions that were open from the previous studies, and of course opening some new questions for some future studies. Paper 1 represents a significant contribution to understanding the biological and psychological basis of musical sensibility, providing a sound empirical framework that can inform future molecular genetic research and the development of more comprehensive models of musical engagement. A strength of paper 2 is the inclusion of both personality factors and facets. As I've said in the introduction, there is really a handful of studies that looked at personality facets in this context. So sensibility analysis that takes into account the same content in different items is an important contribution, and further studies should explore the association with different personality models. And paper 3 has a balanced perspective, acknowledging the study limitations and adding important new knowledge to the literature about motivations in music use. So I hope that I have informed you briefly about all the hard work that has been done as part of this dissertation, and that everything was clear. But if there's anything that I can clarify, please let me know. I hope that the person doing the studies is satisfied how the overview went. So, yeah, that's important. So, I prepared a few topic slides for this discussion between the first opponent and the candidate, and I will try to kind of continue of what I've raised as some of the considerations for different papers. So the topic one that I want to discuss with you is related to personality and personality approach and the personality model used, and what are the strengths of that and what are the limitations of that. So I will just read through that, but we can then discuss all of the points above together. So one is related to, of course, this approach was used for a reason, and it has its strengths. So maybe elaborate why you chose this approach and what are the strengths of it and what are the limitations, and specifically about the specific measure, which was with the BFI2. And then also what we see in the paper free or in the additional analysis, that there's something happening between agreeableness and empathy. So where would you put empathy within the used personality model? And what are the possible alternatives to personality measurement, but also possible alternative to using a different personality model? So that's kind of an idea of a topic discussion. So is it clear what I want to discuss with you?
Yes.
Okay, perfect. You can go any route you want, so.
Okay, so you just want me to...
Yeah, you just start and then we can...
Yes, pros and cons of the five-factor approach used in the studies. So yeah, the hexacle comments in the report, I was not too familiar with the hexacle.
Mm-hmm.
I admit. I really dug a little bit deeper and tried to understand all these different models, and thank you for that prompt. It was actually really interesting, and I was quite amazed by all the disputes between the 6-factor people and the 5-factor people. It was open up a whole new world. So pros and cons of the 5-factor approach used in studies. So more broadly.
Well, what was the reason why you chose the 5-factor approach?
First, it was, of course, because we have a lot of other evidence on
Mm-hmm.
our big research base on the 5-factor, so I think that's an obvious first place to start. And then it's also like the BFI2 is fairly brief. We had a lot of other scales we used as well. And it's also like it has pretty good psychometric properties. It's have some facets, but of course it's a little bit limited in terms of a lower order conceptual scope, I should say. And then it was also, of course, a little bit influenced by my supervisors and what they
Of course.
are using. And then also like for example, the NeoPI, I think you have to pay to use, and yeah, so I thought it was a good balance between mapping facets, but also not that it wasn't too.
So what would be, when you mentioned it now, what would be the reasons to use NeoPR compared to BFI2? And we already said that BFI2 was brief, and what would be the benefits of using NeoPR compared to BFI2?
Well, it's got a broader scope on the facet level.
Mm-hmm.
And also it maps better onto psychopathology measures than like the big 5 inventories. And if I think it all depends on your research
Yeah, that's true. And also related to the empathy, because this is also an interesting question, how it fits with different models, because it doesn't fit the same with within different frameworks. So do you have any thoughts on that?
I don't know. I haven't dug into like how empathy maps onto.
No, I mean, just like your thoughts, it doesn't have to be a true or false question, but more like what's your opinion of it? Yeah. Were you surprised by the results of the regression analysis when you put the empathy in the regression analysis together with personality? Okay.
No, but I mean, like those two facets of empathy have been established before, and then you also have these studies looking at like the similarity and differences between empathy and the different big five domains, and you see like there are quite a bit of overlap between agreeableness and empathic concern.
Mm.
Then fantasy really stands out a little bit.
Mm.
Yeah, I mean, and but we openness was still
Yeah, the same. Yeah, yeah. So why is? I mean, you said that you looked at.
Hello? That's good.
You said that you looked a little bit in Hexaco. So what is the difference for the audience between Hexaco and five-factor approach? Like, what are the biggest differences in personality factors? Which two factors have the biggest difference in terms of?
So Hexaco is a six-factor model, and it's got an additional domain, which is the honesty, humility factor, and that is more like related to moral, and it captures more of moral tendencies and also ethical tendencies and pro-social tendencies, and then you have also openness and extraversion is really similar across the different frameworks, but agreeableness and neuroticism or emotionality, it's a little bit differently conceptualized in the Hexaco model. So emotionality is less about like anger, I think, or it's more pure, the Hexaco people say, pure emotionality. And you also have like the sentimentality facets. And then agreeableness is also, again, the Hexaco proponent says that it's more true to its name in the Hexaco model than it is in the Big Five or NeoPR framework. But I think some says that like the honesty humility factor in Hexaco is just like a repartitioning of the variance in neuroticism and agreeableness, and then this sixth factor emerges. Yes, but I think there's a lot of discussion in terms of which one is best, and I think some says that like neuroticism is better maps onto like more biological systems in the Big Five framework than in, for example, the Hexaco model.
Well, do you think, I don't know the answer, it's just like, do you think that when you would use Hexaco, would it capture or wouldn't overlap with empathy so much, or would it overlap with empathy? So
yeah, that's a good question. I haven't looked into studies looking at the overlap between the two.
I mean, for me, it would be interesting because you see here, one way the variance in five-factor model contributes something to musical phenotypes, then also the empathy. But for us, it would be really nice to have this under one umbrella and not just picking different things. The idea would be to have personality and then incorporate all that we need to study different phenotypes, like musical phenotypes. So this is actually what I'm discussing, is whether we would get something by using, for example, Hexaco model. It could be. I'm not completely confident it would, but it would be interesting. Especially the hexaco also has the altruism facet that's not really related to any of the 6 factors, which could also be important in this terms of empathy variance that could be important for some musical phenotypes. So it will be interesting sometime in the future when someone says, oh, I want to repeat the studies that Heidi Hansen did.
I agree. It would be super interesting. And also, I think that again was, I looked at a study who like compared a lot of standalone scales and tried to integrate them as facets in if that was a big 5, not lexical. And they found like 83% or something of standalone scales could be integrated as facets in one of the domains in Big 5, but fantasy stood out. So fantasy was not one of those scales. So I think like fantasy in itself is something a little bit different, but yeah, I don't know, it's empirical.
Yeah. Does it, do you know maybe when it's compared to fantasy facet in the neo-PR, how much there is an overlap? Because that's always an issue when you look at different measures. You have scales with same names, but they're not really capturing the same thing, or you have scales with different names that are actually capturing the same thing. So it's always exciting to figure it out.
I think in this study that I talked about now, it was like different Big 5
measures.
Yeah. So,
yeah. Because these are all things that have to be at some point thought through and see how to proceed and see where that takes us, basically, in terms of future studies.
I agree. But I do think it's really interesting, this sort of cluster of traits that seem to be associated with musical sensibility, or like more emotional musical processing. And if you think like empathy, openness, and you have potentially the honesty, humility domain of the hexaco model. I think it also would be interesting to look at this together.
And also, we didn't talk about it so far, but also this difference in emotionality, so negative emotionality here in BFI2 and emotionality in hexaco. It could be also that this more emotionality in it could be something that contributes more to explaining some musical phenotypes. Might also add some of the... That's something for future studies. Okay, so thank you so much for this. So my second topic is related to another set of considerations that I raised that are related to sample composition. So one thing that was really interesting for me to see is that you had, well, of course, when we do studies, they're voluntary, and we get people who want to participate in our studies. So the question of representativeness is always there. But it's also interesting to see who decides to participate in the study. It's usually more females than males for most phenotypes, and that's also something that's reflected here. But it's really interesting for me to see the ratio of monozygotic and dizygotic twins, because you have much more monozygotic twins participating. And in the studies that we did in Croatia, we actually have more dizygotic twins participating, which is really interesting. You cannot really explain it just like this. But of course, this influences the stuff that we do, the analysis, because the idea behind the analysis is that you basically have the same ratio of monozygotic and dizygotic twins. So I want to discuss a little bit with you how this can bias the findings that we have. And all our findings are, of course, biased because we cannot have the specific ratio of monozygotic to dizygotic twins. And also, in terms of female-male ratio, you mentioned in the dissertation that no sex differences models were looked at, and so what would we need to look at that? What could we expect based on results that exist for other musical phenotypes, for example? Also in terms of number of pairs, so you had a large sample, but it was divided into those who were in pairs and those twins that were single responders. So in terms of twin numbers, those numbers weren't that high. So do you know maybe how many pairs are needed to actually look at sex differences? And also in terms of age, we also know that some specific effects appear and disappear with age, so this could also influence the results. So these are the topics that would be interesting for me to discuss a little bit with you. Whatever you want first.
Yeah. I mean, I don't know about like the sample composition. I think it's been a trend in Norwegian twin studies at least. Like there's more monozygotic twins than dizygotic. I don't know. And we explicitly said like we need both MSET and DSET. And then also that, of course, like an influence, if you have greater power to detect A, and when you have more MSET twins than DSET twins, I think like from the power estimate, yeah. Was there something else you wondered about? Like?
Well, in terms of my idea behind that, in terms of number of monozygotic twins, it might be related to existing twin registries, because when you have an existing twin registry, maybe then like monozygotic twins are the ones who are more active and more willing to participate. Like just thinking about it, like the data we collected was not through the registry because we don't have a Croatian twin registry, but it was approaching the twins again and again, like a new set of twins, and then you get maybe a different types of or different composition, but of course that's just one of the possibilities. So in terms of like, you get all basically AE models as the best fitting models. Do you know how this twin composition can influence also that?
Twin composition. Yeah, because you have when there's fewer, or when the MSET DSET ratio in favor of the MSET twins, you have more limited power to detect C effects. Yeah, so I think like when you have those kind of samples, you should always report ACE models, and I've taken those.
No, I mean those are the like real life things in this kind of research that we face, basically. Yeah, you cannot really pick the specific number of pairs, and so it's more of like I've started like always reporting the ACE model with the zeros and everything, because it's, I think, more fair than any other decision, because with the number of twins I have, it's the best decision that I can do.
Yeah.
So yeah, that's it. And do you know how many twins are needed to do the sex limitation models?
No,
in the thousands.
Yeah.
So, yeah. So again, it's really the case of like, even when you have this large sample, it's really something that I've never had such a large sample when I did my twin studies, but still, it's not powerful enough to detect some specific sources of variance. So we can always talk about, we need to do this and this kind of variance decomposition and everything, but we're always limited with actual numbers that we have in our samples.
I don't remember if the music reward study tested, because they had quite a large sample, but I don't remember if they tested the sex differences there in the new study that came. But I think I read somewhere that unless there are very obvious like phenotypic differences, then you wouldn't at least expect the qualitative sex differences. So, and I wouldn't expect that in the phenotypes that I've...
Maybe you should just, like, for the audience, say what's the difference between quantitative and qualitative sex differences. Yeah, just like we're discussing this, but...
yeah, so quantitative sex differences means that, for example, genetic effects are stronger, or yes, in one sex over the other, and then you have qualitative. Then, if there are qualitative sex differences, then there are differences. There appear to be differences in sort of the genetic underpinnings to some extent. Yeah. Ish.
Yeah, it's the amount of heritability, or like what we saw in the heritability estimate. So A could be lower or higher for different genders, or we can have different compositions, so more shared environment or existing shared environment, and so on. Okay. So the first thing is the age-specific effects. So tell us more about your sample and what age they were, and do you think that these phenotypes that you measured do change with age or not? So what do you think? And do you think that there might be some specific genetic and environmental effects that change with age? I don't have a clue.
Yeah, I mean, at least one of the subscales, like the personal commitment subscale, is likely to. I remember they found it in the music reward, like the four subscales there, like trends, like the musical seeking part goes down as we get older. So there might be, but yeah, I don't know. And what was the second question? Like,
well, let's go back to like if like I would expect there are possible differences between two phenotypes, so between musical sensibility and music motivations in terms of age. So would you expect that to be different, that one changes and one don't, or something like that?
I mean, if we conceptualize musical sensibility as a rather stable and it's like a more basic responsitivity, then I think it should be quite the same throughout the lifespan. But if you look at motivation, yeah, like social dimension. I don't know if it's so relevant it's relevant, but I think I also read somewhere that typically that declines a little bit when we get older. You don't have.
Yeah, I would. Yeah, my expectations would go in some way, so that musical sensibility might be more stable. So it shouldn't be that important if your participants are adolescents or adults or whatever. But for motivations for music use, I would expect differences based on some other findings, like, for example, how the importance of music changes throughout life. So it's something very, very important for adolescence and young adulthood. And it doesn't stop being important, but it's not that important, like in the age group that was the sample, the average sample age in your study. So there might be some differences in terms of both variability and also the causes of this variability. So it might be something that's related to also age and also some specific effects that might appear and disappear throughout our lives. So it might be worth exploring more in terms of like different age groups than musical sensibility. But of course, this was just a hypothesis, so it would be better to explore both and then like to see if we are right about the musical sensibility. But my expectations from some other investigations would be that there might be a difference between those two musical phenotypes.
Yeah, I hope we get to do a longitudinal follow-up.
Okay. And so my third topic is related to things that you've mentioned in the dissertation, like testing theory-driven multivariate models, or testing the existence of shared environmental influences. So my questions are really specific for you. So what would you do to test the existence of the shared environmental influences? Would you change the research design, or?
Yeah, then I guess you would need an extended family design to get better.
Okay. What's the extended family design?
To include either siblings or parents of the twins. then you can.
Okay. Why? What that offers us?
In terms of the shared, I'm a little bit blank.
Okay. Do we need such a large sample to get information about the C factor if we had this additional information?
Possibly.
Probably not. Yeah. So
Yeah.
you can get by a smaller
Yeah, okay, yeah.
sample because you have this additional piece of information. So it can be like, if we know, like for example here, there might be something worth exploring in terms of shared environmental influence. One way to go would be to like change a little bit the research design and capture this. Yeah. What about the common versus independent pathway models? So what's your gut feeling about that
A
one?
gut feeling that it wouldn't fit.
Okay. Did you play with it, maybe?
No, it's based on, I have some, because, okay, two things. No, yeah, let's start with the first. Because we did actually do, in the first paper, but we took it out because the reviewers were skeptical regarding power and that we should do simulation studies, but we actually did like a full multivariate item level analysis of just exploratory, and so not in a common pathway context. But we did find again a very strong like first or dominant genetic factor, but the environmental influences seemed a little bit more like three. Yeah, so I found three factors, and one like the emotional and the memory and imagery subscales are mapped onto one each, but then you had like the listening sophistication and the personal commitment who mapped onto like the same factors. So there seemed maybe to be some extra additional shared and non-shared environmental covariance.
Yeah, things get, what we see in the trial, things get messy, right?
Yeah. So I think like based on that, no, it wouldn't fit. But I find that that whole common pathway and independent pathway, I think is so interesting, but at the same time, like keeping in mind like the limitations of fit statistics in this context. So like the validity of fit guided inferences in this context is a bit tricky. So it doesn't really tell you much if it doesn't fit, because it can be for a number of reasons. So I'm much like now that we are more in a exploratory space or descriptive space, then I think it would be so much more useful to use more like hybrid or models. I've seen like Timothy Bates have done a lot of cool stuff with this more hybrid models, and then you can learn more about the actual structure instead of just fitting those
fitting
two,
the specific
and then you don't really know what's going on under the hood. So but I mean, you have to really think about how to approach this, because there's so many ways to do this and so many researcher degrees of freedom, I think. So I think really, I want to sit down and think about how to.
Yeah, but also the power problem, what you mentioned. I mean,
absolutely.
Some things look really interesting, and that it might be an interesting way to go, but you don't have enough participants to run them. So
but to do some simulation work maybe, or I don't know, but unless you have like a very strong theoretical foundation to assume one over the other, I mean, so Timothy Bates, one of his study with the hexaco actually, they sort of postulated that the A and D effects should be through a common factor because of like the theoretical conception of personality as basic tendencies and also like adaptive characteristics. And then they model like E influences separately, so based on theory. And so if you think there are so many ways to do this.
Yeah, maybe the when you're saying that, I'm coming back to the question you posed in the dissertation related to like, are these things like two separate models, or should they be like combined somehow? So what are your opinion on that at this point? When you look at the correlations between musical sensibility and music motivations use, especially with two facets, they are quite overlapping.
Yeah, I question, like, even though like module 4 is prompted in a different way, I don't know if participants are able to catch that difference. And I think like that is an issue with many of the instruments that we use in music psychology, and we also have so many different names like functions, uses, motivations. I got so confused. So I think like I would really like to like sort that out a little bit, but in this case I don't think they.
Yeah.
At least the transcendent subscale and like musical sensibility, and perhaps also the identity is very similar.
Yeah. I get a feeling that we kind of miss, as a research community, the place where different people doing the same things come together and then just like make. So this is this, we are going to call this, and we're starting from this proposed idea behind our phenotypes, because otherwise you get this like really different measures and different scales and different names or same names of different things. And then especially when you start looking at something, then you have to decipher if these are actually like same things or overlapping things, and how to combine them in your own research. So yeah, it is overwhelming.
It is, and it's a little bit, it's a little bit of a pet peeve. But yeah, I think like that's where like Big Five and stuff come in, because you have this integrative framework to. Yeah, I would like the same.
But even here, you see there is.
Yeah. But I would like the same thing for music psychology, like to have a more, more collaboration around these things.
Well, I hope, because what we see is that there's more and more research into music psychology now, and so I think hopefully that this thing will happen at some point, and that will kind of clear out the mess and make it more clear what we are measuring and what we are calling with different specific names. Because also with you kind of changed the names from the Münzerbach inventory, because it didn't really feel like the right phrasing of what's beneath it and what's defined as musical sensibility. So these are all the things that can be thought about differently and used differently in research. So that complicates things, of course. So would you recommend using the two modules based on your?
I have more experience with module 2 now, like I know that much more, and I think yes, I think it looks reliable. It conceptually makes sense, I think. I mean, obviously more work to be done with that, and maybe include some additional facets. In terms of the module 4, yes, I do, but I think more psychometric work is needed, and perhaps, like I think I mentioned also, like in the emotion regulation subscale, the items are worded much more in a motivation or use kind of way. So if the items of the whole scale were worded in that way, then maybe it would become clearer, but I don't know. I would like to look into it further, like the two modules, how they overlap.
And also when you now mention the emotional regulation, coming back to the age differences, that can also mean different things, for example, in different age. Because, you know, how my daughter is using music for emotional regulation is a bit different than what I do with music for emotional regulation. So this can also influence how people from different generations and different age groups approach the inventory and how they reply to the questions, and then again what we get out of it and what goes into the analysis. So that these are all like important questions that we need to have in
Agree.
mind.
Mm.
Yeah. Okay. Yeah. Interesting future
Yeah.
awaits for everything. So I think I will stop now, if that's okay with everyone. And
Okay, I would like to thank the first opponent and the candidate for their efforts, and there will now be a 15-minute break until 10 minutes past 2 or something. We will now continue the public defense of candidate Heidi Marie Umbach Hansen's dissertation. And I hereby yield the floor to the second opponent and the candidate.
Do you hear me also in the back? So Heidi, the reason I put chairs here is that I wanted to make this a conversation. It's not only because of my knee. So instead of examining, I wanted to turn this into a discussion session. You delivered your work. We grilled you during the previous phase where we made the comments and suggestions and points of critique, which you all answered very admirably. So the time for grilling is over. I want to use this time now, this last chapter of your PhD process, to facilitate growing your growth into a scientist by not asking you questions, but giving you the opportunity to ask questions, to pose questions, questions that you might have had at the beginning of your PhD that got not answered by your work, questions that arose during your PhD that you think are worth pursuing now, questions that you have now for future projects. So what is it that gets you get up in the morning and drive your research as a scientist? What is the big goal? What is the big question that you pursue now? That you want to, what's the question where you say, I want to find out this XYZ thing?
Oh, wow. That's a big question. I mean, music, of course, is something I really, really, really care about, and I really have so much faith in sort of the broader implications of music in therapy, and I think now having begun to study and think about like music and emotions, and we know that's crucial in pathways to health and to well-being. the main, like the, can I repeat the question?
Ask me things.
Yes.
What do you want to know from me and from science, and like what's driving you? What are the new knowledge gaps that you found, and where you think, well, this is something that I need to answer. This is something that I want to answer. This is something that I think we as a scientific community should address now. Where you know, if you think in terms of like signposts, where do they point to which direction? What would you want to do? What do you want to find out next? And how can I help?
Facilitate that, yeah. I guess grants would be nice. No, I think in my case, I would say, I mentioned it earlier with Anna as well, like one of the things that I find really intriguing is this combination of traits, like if you think of it more broadly, like environmental sensitivity, you can think of musical sensibility, empathy, these socio-emotional traits and moral tendencies, like why do we see them clustered together and why, and by extension like neurobiological mechanisms underlying that. So that's one thing I would really like to explore, and also more in relation to sort of more physiological markers of musical sensibility and that kind of path. I don't know, I have many things I want to do.
Do you have something in the back of your head with regard to specific, let's say, neurophysiological or peripheral physiological markers of musical sensitivity?
Yeah, for example, do we actually see like any physiological markers when we look at in relation to this, like a more endophenotypic perspective? But I also, I think like one is looking more towards like the physiology and neurobiology, but then also like in a broader perspective and the broader theoretical implications of traits like musical sensibility or similar. I think a lot, or not a lot, but there's been more done, I feel like, for example, Music Reward, you have Sator and the group, they have done a lot of work looking at neurobiological mechanisms, but I think like a more broader perspective in relation to psychological traits and everything, then that will be super interesting. But I'm curious to hear your thoughts.
With regard to the physiological markers, what were you thinking of? Is there anything that you have in the, where you have an inkling, or where you have previous observations, or a feeling that there might be something? I'm also asking because in the beginning you mentioned links between, let's say, musical sensitivity, maybe also links between the motivation to use music, these two bigger constructs that you investigated, and well-being, as you mentioned, or maybe therapeutic effects. So there might be an interesting link, right, between physiological, let's say, peculiarities on the one hand, and possible keys of musical sensitivity or the use of music to, let's say, provide therapeutic benefits or benefits for well-being. That's why I'm asking, which kind of physiological markers were you thinking of?
Pupillometry, for example, or like, the thing I was thinking about is like, are there any more, like we have this construct from a scale, but do we see any physiological correlates in terms, for example, if you have high musical sensibility and you listen to music, do you see a greater responsivity in those people than compared to those without? And yeah.
Is musical sensitivity, is there any patient group also that you could think of where musical sensitivity or the motivation to use music is different than in other groups?
Good question.
Is there a way to kind of enhance musical sensitivity or the motivation to use music?
Through like
Let's say for
interventions.
yeah, well, maybe not necessarily interventions, but let's rather think first, maybe like in pedagogical terms.
Yeah.
Is it something that we should bring into preschools, let's say, and or barnehage in Norwegian? Is there something that we should do to increase musical sensitivity in children? Maybe the motivation to use music. I mean, there would be ways to, let's say, use this as a vehicle to practice emotion regulation was one of the facets, right? For example, social connection was another facet, all essential for the well-being of children, let's say.
Yeah.
And,
That's interesting, and I saw also your recent work with resilience and active music.
I was just thinking,
Yeah.
would that be a key, or would that be a window, would that be a way to use, let's say, as a preventive measure,
Yeah.
if you will, for mental health conditions,
Yeah.
for example.
I agree.
And then, sure, physiological markers in the sense that, on the one hand, with regard to, let's say, therapeutic processes, because in many disorders and diseases, certain physiological parameters are out of balance. But on the other hand, maybe also even to detect, help diagnosing.
I haven't thought about that. I haven't. I only thought about like anchoring like these concepts in more neurobiological or physiological foundations. That's what I'm curious. I want like almost in my thesis, I want to dig down and I want to dig more broadly, if you understand what I mean.
Which direction would you be most interested in looking at in this regard? Because you come from neurochemistry, neurobiology background.
And then I've fallen for psychology.
Where would be the... Well, you in your lecture you made the full circle.
Yeah,
Why
yeah,
not also
yeah.
do that in your life as a scientist?
Yeah, I hope so. And I think like now, getting some distance from like my PhD work and then trying to see from like a broader perspective is I'm understanding more and more every day, I feel like. But I don't know. I think really, I can't decide it really. It's
What would be the first molecules you would look at? Like
Oh,
the
wow.
first, the first proteins, the candidates, the top candidates for you. I mean, where you would say, well, that's something that would, get out of bed in the morning.
I think it's rather like I find so many of these things so interesting. So I think it's
Name one.
yes, but I think it's more a matter of narrowing my focus. Yeah. I mean, my neurobiological understanding is not up to date, so I wouldn't like to speculate too much on that. You have much more knowledge about that.
Oh, I doubt that.
Yeah.
Well, for example, you had this hypothesis in your lecture, which I found very interesting, that dopamine, and correct me if I'm wrong, drives motivation to obtain primary rewards, and for secondary rewards, it might be more endogenous opioids that intensify the pleasure. Yeah. So I was thinking, but I know it's a huge debate and I don't expect us to answer this today, but social connection, is that a primary reward?
I think it is. Yes.
It is, isn't it?
Yeah, yeah.
I mean, when we say, oh, yeah, sure, sex, food, but social connection, is that also, I mean, for us, at least, you know, as mammals, primates even more so humans, social connection. Can we consider this as a primary reward?
Yeah.
Yeah, I would agree.
Yeah.
Wouldn't that mean that obtaining this primary reward by music, by synchronizing together, by engaging together in music, that makes it a primary reward, no?
Yeah.
Not just a secondary reward, but I know it's an intricate discussion. I was wondering how to further kind of test this. If you ask me, I think we just need more data and more experiments that kind of make the picture a little bit clearer, because, you know, for example, the pharmacological studies with naltrexone, one of the ones that one you showed here, I think how many are 4 or 5 studies in total? I think so far, right? I found it interesting, again, correct me if I'm wrong, that the pupil width for chill moments, that was significant, but the pleasure ratings were not.
The pleasure ratings were the same, or yeah, so that didn't change, but it was like the objective measure of physiological responsivity, and that's like, even though the 4 or 5 studies that have done this so far are like, it looks a little bit inconsistent, but when you like look at it a little bit broader, then that is what they found in every study, is that the objective measures go down when you use opioid blocker, but not the subjective ratings.
I was wondering, you used a 50 microgram dosage here, right, in that study. As a neurobiologist, do you think like doubling, for example, to 100 doubling the dosage, would that maybe lead to a stronger result? I think it'll create a whole bunch of problems with the ethics board again, I presume.
I think it was found in one study using the same dosage that you use, that it was like 90% opioid blockage, receptor blockage. But I don't know, yeah, something like that. But I wouldn't, I don't know. And there's also different kinds of opioid antagonists, aren't there? Like, that been used in these studies. I mean, it's preliminary. I think there's much more to be learned. And in neurochemistry in general, and music,
Yeah, it's not just the music.
No, in general.
In general, is difficult to
Yeah.
investigate in vivo in humans. Of course, especially when you want to look at brain structures, brain networks, etc. You basically only have PET to do this, and there are only so many tracers for only so many neurochemicals. Do you have any experience with different, let's say, opioid receptors from your previous work? No. Yes. There was another thing that really, it's just for me to learn. It's not to grill you anymore. So the muse back. If, let's say, I had a student, and the student did we do a music study, and the student asked me, why should I use the muse back instead of the, let's say, the gold MSI? What should I answer that student? Because the gold, I'm just saying for the audience, the gold MSI is another instrument for measuring different facets of musical competence, musical engagement, musical cherishment, if you will, with many items that kind of overlap with your inventory. The gold MSI has been established over a long period of time, right?
Many people.
By many people have used it, etc., etc. You can combine, it has also different scales, etc., etc. So, and to be very frank, don't tell anybody outside this auditorium, I haven't heard of the muse back before I read your
a lot of people haven't.
thesis. So naturally, you would ask the question: why do another instrument when we are actually trying to achieve more homogeneity? And there must be a very strong reason why you say, well, it's so much better. It should be used instead of. So
No,
tell me how I can convince my students.
it depends on your research question. Are you more interested in like gold MSI is very much about like abilities, like are you a good singer, are you blah blah, blah, and then also active music engagement. So it covers more of that. Whereas Musebach, for example, module 2 is more, I find it at least, just inspecting items and content that is more like this basic responsivity, like emotional engagement. So, of course, a gold MSI has that as well. So if you, but it's less coverage, and I think you have
Less coverage of what exactly?
The emotional component.
I think it has like what, also like 12, at least 16 items
for the emotional
emotions.
subscale? No, I think it's 6 or something.
Oh yeah. So your argument would be that for the emotional side of music, it has a broader coverage.
In the Musebach, yes. But
specifically in the music, in the second module.
Yeah, or if you look at it like the motivations for music use are more like music-seeking behaviors and like what kind of patterns. But if you look at least how I view it is that module 2 is more about like this basic emotional engagement. So, but gold MSI is very good, but I think for our purpose, where we were more interested in the emotional component, then Musebach was a better fit, and it also had like module 1 is like music engagement, like both amateur and professional, and then so you got greater coverage. So that's why we chose it. Whereas in the gold MSI, as I said, you get more in terms of active music engagement, like you used in the resilience study, which of course can be very insightful. So yeah, so it depends on your research question is where what I'm getting at.
Yeah. Then when it comes to the motivation to use music, many people, some people discuss diversion as an important motivation. Pastime, for example, have music. Yeah, that? I mean, correct me if I'm wrong, but that is not among the 4, right? No. Was there a specific reason? Were you involved in the development of
No.
No.
I think they had items that covered that, but it didn't turn out to be like separate subscale. But yeah, I agree, and I noted that in the paper as well. Like for a lot of people, music is more like just background, not
pastime,
yeah.
and just yes,
or
diversion.
doing physical exercise, you need some arousal, or it's more functional in a way.
Yeah, right. Although this almost goes already a little, maybe a little bit in the direction of mood regulation, which is included there too. Yeah. Yes. So now, coming back to my more previous questions, let's say you got this huge grant, or somebody came along and said, "Well, here's $1 million. Go ahead and answer what you want to know." What is it? What you would do? What would you do?
I would. $1 million, or did it? No, I would. I would like to do some of a kind similar study, like to get longitudinal data. I would love to, again, look at more some of the physiology maybe, and then also, like I already mentioned, I would like to map it broader in psychological, in a psychological context, to broader life outcomes and but in a twin study again.
Are you more interested in that just to see how these specific, let's say, musical aspects, like musical sensitivity and the influences health and well-being, or more like from the other side, like you want people to be healthy and feel well, and which factors contribute to that? I'm just asking in a more general sense, because we were also discussing that among the committee in completely different contexts before, that once you set up a music study, you need control groups anyway, and the typical factors that contribute to health and well-being are, physical exercise, good sleep, nutrition, emotion regulation too, and that's also where music comes into play, and social connections. Again, music comes into play, but not only. Many people do sports together with others, especially if it's team sports. There's also social connection involved, obviously. Many people do cooking, gardening for recreation because it calms them down, and peacefulness, so that's the kind of emotion regulation. So if you want to set up if you wanted to set up a study, would it be, depending on the design that you will ultimately develop to put in your grant, it might actually be a good idea to put in, several different factors to see what kind of activities do actually lead to well-being, health, music being one of them. What's your take on this?
Yeah, certainly. Like, music is not the only path to whether it be positive mental health or physical. I don't know. I haven't thought along like the lines of doing more explicit music therapy work or something like that, but I've been thinking more about, for example, thinking of music emotional engagement perhaps through, for example, other theoretical lenses like Barbara Fredrickson's like broaden and build framework, because that's like joy, interest, curiosity, like more epistemic emotional side, to think about it more in that context, but I haven't really thought anything about intervention design or...
In children also self-efficacy, I think, that they develop with, let's say, mastering an instrument or dancing, singing, what have you. I think what's very special about music is, one, how instantly it can change things. It can instantly distract our attention from, let's say, negative thoughts, negative memories, what have you, to the music. We engage with it, we move with it, our mind is occupied. So the executive network is engaged, default mode network is kind of disengaged, anti-correlated. I think that's one thing that's very special about music, how quickly and how powerful it is in distracting attention and engaging us in something completely different, which may be better for us than engaging in the negative thoughts and emotions and moods. And the second thing I think that is very special about music is how it brings us together, how it kind of, in a large crowd, very quickly fosters like a feeling of unity and belonging, and being part of the tribe, and being part of, let's say, the social fabric. We were talking about Taylor Swift and Swifties. I don't recall whether you were there when we talked. Yes.
I don't know how long the discussion. Okay.
I think that's something very special about music, when you have, not just in a stadium where the whole community sings the songs and they have their movements and they feel being part of something bigger. And I think that is something that we humans deeply need, to be part of a social group. But of course, also when we go into the classical concert, we don't, it's frowned upon if we sing along or clap along. But still, there is this protocol. We clap when they come in, we clap when they go out, and there's a certain, participation as well. And that must also somehow relate to the musical sensitivity, for example, indices that you investigated.
Yes.
How are we doing time-wise, by the way? I'm just, because I keep, I don't. All right. So I was actually hoping that you would ask me questions about, designs or design questions, experimental design questions, while you were thinking, I was wondering how to achieve this and that. Do you have an idea? Is anything in that regard bobbling in your mind?
I've been so, my mind has been so zoomed into twin studies and doing more of the same thing, but in a more informed and broader context now than we collected data the first time, because I really do see a lot of value in that work as well to complement neuroscientific work. But so I haven't really thought about it, but I would really love to know what you think are the most exciting paths now moving forward, from a neuroscience perspective, what are the frontiers in that regard? But yeah, I'm sorry, I haven't thought very much about experimental design.
Yes, I think many different things would come to my mind there, but one thing that you mentioned also in your lecture was the exact function that the hippocampus plays when it comes to music-evoked emotions. The fact that it links social bonding through music to the attachment-related emotions and the positive emotional experiences and the feelings of reward and happiness is, I think, physiologically speaking, a very plausible hypothesis. Especially you, coming from animal work, know all about this. But there is not really neuroscientific evidence for this. So that's something that I personally would be very interested in, of course, to really establish these links. Not just with functional neuroimaging, but even more so with PET imaging.
For the neurochemistry part?
Yes.
Yeah.
And then dopamine, for example, and endogenous opioids, I think that would be really cool.
I agree.
That would be a really step forward. It's not trivial though.
I remember reading the 2013 paper by Levitin and Chanda, and it was
Also,
I want to go into this, the neurochemistry of music.
The TICS paper.
Yeah. It was I want to do this, but yeah, it's complicated and it's difficult to get good measures, I guess.
Yeah, I wanted to do some PET work. I spoke with PET specialists from Norway, and they say 11 carbon tracers is going to be very difficult in Norway. But we have an EU grant now where I want to try to get approval for reclopride to measure dopamine. So let's see how that goes. But it might be necessary to go to labs in other countries doing that kind of work. And I've been searching for labs that do this kind of work, and there are surprisingly few around in Europe. So yeah, worldwide actually, it's not easy to do that. So I think in that regard it would be great if we could forge an initiative in Norway where we get a lab up and running that can actually do this kind of work. Let's say 11C reclopride for dopamine, 11C cofentanyl for opioids. There are also tracers for kappa opioid receptors now, vasopressin. Unfortunately, not oxytocin yet, but maybe, you never know, it could be. I mean, it's been very, very difficult so far. And so I think that would be really exciting, something in this regard. And should we get approval, I'll certainly contact you
I will love that.
and try to get you involved. All right. Do you have any other questions for me before? Because otherwise I'm going to close the session.
I think I'm question out. Or
Brilliant.
Yes.
So thank you very much for your
Thank you.
time
Thank you.
and for your brilliant work. And then...
I would like to thank the second opponent and the candidate for their efforts and for their very interesting discussion and conversation. No one has asked to speak as an ex-auditorio opponent. If anyone still wishes to do so, please speak up now. Okay, would the candidate like to make some closing remarks?
Yes, I can try. Might not be able to. Yes, of course, I want to thank you guys for your time and for your thorough work and your comments. It's really, it was really helpful, and I really learned so much more also, so thank you, and thank you for the great discussions today. And of course, I want to thank the psychology department and University of Oslo and my wonderful supervisors and co-supervisors, I should say, or mentors, Olav, Anne, Nikolai, Tor, and all my wonderful colleagues at both Remo and Promenta. So thank you all so much for the support, and my husband, my family, I should forget. I'll thank you guys later. Yeah, I'm getting emotional.
Thank you so much. Please stay here. You have to stay here a little bit longer, please. The defense is hereby closed, and the rector of the University of Oslo and the university board will be notified. And on the behalf of the Department of Psychology and the Faculty of Social Sciences, I would like to give you some flowers and a gift.
Thank you. Thank you so much.
Okay, fabula acta est.